So first of all, where does, who's F in number 13?
G.
G, yeah, okay. So technically we're going to take that definition, and anytime you see an F, we're going to replace it with a G. Okay, so the very first part of critical numbers is if G, if the function G exists at T, good. So if a function G exists at T equals C, and G prime of C is either 0 or C. Okay. So the first thing we're going to ask ourselves is, what is the domain of G? Why are we asking ourselves that? Well, what's the very first part of the critical number part? The function has to exist. So before we even think about derivatives, the function has to exist. Well, how do we know where the function exists? We think about where it doesn't. So, kiddos, is a square root one of those types of functions that has a domain?
Yes.
What can't be under? Negatives can't be. What can be? Positives and 0, right? So can't I go ahead and do the whole little like, 4 minus t has to be greater than or equal to 0, therefore, I was helping a little kid, a little 7th grader, he's a son of somebody in my small group last night. He had a test today on solving algebraic inequalities. Can you guys do it?
I don't know.
What's t?
4.
It's not equal to 4, it's a range of numbers. Is it greater than or equal to, less than or equal to?
Less than or equal to.
Less than or equal to. How did you do it?
I subtracted 4.
That's what he should have done too. But we're beyond him. We should be, right? Wouldn't it be easier to add the t to the other side? Oh, t has to be less than or equal to 4. Rather than subtract the 4, divide by a negative, and remember to flip the sign? Now, for him, is it good that he has a system he should always use?
Yes.
Yes. Always do the addition or subtraction first, then do multiplication or division next, and if it's a negative, what do you always do to the inequality?
Flip it.
Flip it. Although he had some nasty decimals that you guys would have freaked out on. He was just like, oh, whatever, I can do that off to the side and do 1.6 divided by, yeah, I already lost some. Anyway. Sad how lazy we get in math. But long story short, should you know that t is less than or equal to 4? Okay, so if I find any critical numbers that are greater than 4, what should I do to them? Say that they're illegal across the map. True? Is there anything stated, anything else stated for me that I need to consider about what legal values I'm looking at?
Less than 3.
Oh, so I mean, domain-wise, it has to be less than or equal to 4. They're saying only the ones less than 3. Okay. So, have I figured out where the function exists? Yes. Have I thought about anything extra they gave me? Yes. So now it's time for the next part of the card. If a function exists at C, a special critical number place, wait, who are the C's? When the derivative equals 0 or, but to do that, don't I have to find the derivative first? So why did I tell you guys to take a derivative while they were doing announcements? It's a huge part of critical numbers, right? So, should have done a product rule. We can rewrite this to be 4 minus t to the 1/2 power, if that's a little bit easier. So, second, b first. What's the derivative of t? 1. Plus first, b second. How do I derive a u to the 1/2? To the times? Who is u prime? 0 minus 1. Good. Does that make sense? Try to bring down the 1/2, take the whole thing and make it to the negative 1/2 power, then times u prime. And just a few of you have gotten used to, oh, hey, isn't that like a 2 down here with a square root down here? You're exactly right. Just don't forget the negative 1 times the t. And then, can you guys look really quickly at the backboard and the note that I have written off to the side? How do you do with homework? That's you and mine.
Get those derivatives simplified.
Yep. Why? Is this simplified?
Definitely.
No. Hey guys, with your critical number forever card, didn't I do some sort of hint about ones that had fractions? Split up the top and the bottom. Wait, the top and the bottom, the numerator and the denominator. Does this just have one numerator and one denominator?
No.
Nope. What about this guy? So is it simplified yet?
No.
What are we going to do?
combine them.
Combine it to have one top and one bottom, but legally, mathematically, how do we ever combine fractions?
You have to multiply on common denominator.
Common denominator. So, somebody yesterday was looking at something, I forget what. Oh, Kathleen, you're looking at the example from period 6, because they got this one done instead of that one. You guys just did this one instead of the other. And she was like, what is this whole thing off to the side? Guys, what was I doing when I wrote this yesterday in period 6, or when I'm writing it today in period 10?
There's the common denominator.
Give me a comment.
Can you reduce this from something?
Don't go canceling out anything. We haven't even gotten our common denominator. Don't go killing those kittens yet.
Don't go breaking my heart.
Hey, a square root squared. Doesn't the square root go away? Is that good?
Yeah.
And then that's going to be 8 minus 2t minus 1t, 8 minus 3t. Is that the best form of the derivative? Yes. Why? Because it's a single fraction. Are we good so far?
Yes.
What have we done? We talked about where g exists, because that's where the forever card starts. We figured that out, and they were like, okay, we need the derivative to do that whole 0 dne thing. We saw that we had a fraction, so we got common denominators to have a single top and a single bottom. I think Mariah, you were the one who said once we have the fraction, split it up, basically, right? So that little pitchfork, I'll try to make Adam happy and leave like a little middle part, even though that's not really anything that we use, but he was sad that there was no trident or something. I don't even know. Anyway, we're going to take the top, set it equal to 0, take the bottom, set it equal to 0. Why? Because I'm looking for the zeros and the, wait, it's a fraction. Why would I be setting the bottom equal to 0?
Make sure it doesn't equal 0.
No, we're not making sure it doesn't equal 0. I want to see when it's undefined, so that's when the bottom will equal 0. Why? It's a fraction. If it wasn't a fraction, would I be setting the bottom equal to 0? Well, no, I wouldn't even have a bottom. Or I would, it would be 1, so it wouldn't really matter. So I have to consider who the derivative is. The easy part is setting somebody equal to 0. We've been doing that for forever. The hard part is, when do you not exist but a fraction? It's when the bottom is 0. Anyway, long story short, has anybody solved? What's this top one give us? T equals?
3/8.
8/3. We subtract the 8 and then we divide by a negative 3. 8 over negative 3 is positive 8/3. Take your time and do what you need to do. For some of you, could it have been easier to add the 3t and divide the 3?
So doing that now.
Yeah, that might be smart. How about this guy?
So you divide by 2 and square both sides.
Or you just look at it and say, what would t have to equal to make a 0? Right? I mean, the square root, if t was 4, I mean, I get it. But you can't divide by 2, you can't square both sides. I mean, it's 0, 0, 0. 4 minus t is 0, which happens when? Add the t. T equals 4. Okay, critical numbers. Whew, I found them. This guy would be my 0 category, and this guy would be my D and E category, right? Boop. So, those are my 2 critical numbers. Dun, 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 dun. Wait a minute. Done.
Because 4 is above 3.
Thinking back about the whole existing thing. Wait, 4 was fine! But what did they tell me? Oh, just they said keep it less than 3 for whatever reason. I don't care.
That's not too bad.
Yeah. Remember, well, is it though? I mean, some things this chapter, yes, but here's the dilemma. You ready? When would an equation of a tangent line question be scary? What would make an equation of a tangent line hard? Y minus y1 equals m times x minus x1. When would it get hard?
When you have to find the slope.
Okay, and finding the slope, you have to use the derivative, and sometimes derivatives are hard. Does that make sense? So when is a critical number question going to get hard? When the derivatives are hard. Now, was this derivative hard? But was the simplifying a little tricky? So, where is it going to get hard? The derivative, and or the simplifying, and or what to do to it. A tangent line just says plug in an x and or a y derivative, simplify, When does he equal 0? Oh, no big deal, just set equal to 0. When does he not exist? I have to think about it. That's when it would. Does that kind of make sense? So can we take somebody else who, was he a fraction to begin with?
No.
But did his derivative end up with fractions?
Yeah.
And that's why we did the whole top equals 0, bottom equals 0 thing for the zeros, DNEs.
Yes.
Can we take someone that looks a little bit different and see what happens with him? Ready?
Since the LN.
I'm not saying there couldn't be an LN, but let's just take what we have and deal with him. Not has enough worries of his own. I mean, the next problem has enough worries of his own. Box triangle, are we good?
Yeah.
Wait a minute. Wait. What was the first part of the definition of a critical number? If the function exists. Oh, wait. Let's think about domain. Okay. This guy. He doesn't have a square root. He has an exponential. But is exponential bad?
No.
What's the basic graph of e to the x, or kind of any b to the x? Basic graphs. Show me. Nope. Well, I mean, that's like a weird decreasing one.
Yeah.
There you go. Thank you. Yep. Good? Are we okay? There he is. What's the domain of any exponential function? Negative infinity to positive infinity, no vertical asymptote, no breaks, no holes, no jumps. Oh, he's fine. All real numbers. How about him? All real numbers. He's a polynomial. All polynomials are good. Long story short, does he have a square root? No. Does he have a denominator? No. Does he have a log? No. Does he have a trig with a weird vertical asymptote? No. He doesn't have any of the problems. If he doesn't have any of the problems, what's his domain? Everybody. So is anybody going to get canceled out or ignored because the function can't exist there? No. Okay, good.
I like that.
All right. Now we need to find g prime because the second part of the critical numbers is if the function exists, check everywhere, doesn't matter. And the derivative equals 0 or DNE, well, we have to go find that. So, second, D first, plus first. Ooh, do you remember Boolin? Boo? Why is there a times 1? Derivative of any b to the u is b to the u, like e to the x is e to the x, times ln of b, oh yeah, it's not an e, times u prime, wait, but where'd the 1 come from? No.
Nope, the derivative of the x.
Yes. X prime is just 1. If it was an x squared, it'd be 2x. If it was a 7x, it would be a 7. I don't know. Whoever he is, just take the 7. First of all, can this expression ever not exist? Because we have to think of zeros and DNEs. Can this function ever not exist, this derivative function? There's an ln of a number. Oh, wait a minute. ln of 3. Can I plug that in my calculator? Does it work?
Yeah.
Is there an ln of an x I have to be worried about? Any x in here? No, it's just a 3. Oh, that's just a number. So ignore him. He's just a number. Do I have any square roots? No. ln's? No. I mean, that's just a number. Any denominators? Nope. Any trig? Nope. Guess what the domain is of the derivative function? All real numbers. So this guy will never not exist, so I can ignore that whole part of the forever card. But what else do I still need to look for? Zeros. There are 2 things I'm looking for, zeros and DNEs, right? So DNEs will never happen. Yeah. Zeros, well, that's easy. We did that a long time ago when we just took things and set them equal to 0. It's called x-intercepts or solutions. But wait a minute. How do we find the zeros of any equation?
X by itself.
Don't we have to think factoring? Pause. Green rule trick. Haven't used it in a while. I pull out my green pen and I start drawing little lines when I'm showing you that really it's a plus of 2 objects, 2 terms. And you're just asking yourself, is anything in common? Yeah.
3 to the x and 6.
3 to the x comes out, and what else?
4x.
Is that 12?
No.
Why? Property of exponents. You can't combine. If the bases are not the same, that's 3 to the x and 4 to the 1. Nope, 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 nope. What's left? I think it's a 2 plus an x ln of 3. You guys agree?
Good.
So I pulled out what's in common. I'm factoring because that's what I always do when I go looking for zeros. I always factor. This just looks weirder than those polynomials that we used to do. I'm just writing down what we're doing. We're looking for the zero of the derivative in search of the critical numbers. And the d and e's for this guy are impossible because this derivatives, things are happening every day, is all real numbers. Yes, we know. Anyway, Cinderella Broadway, great. What do we do now? Find the, what do we do after we factor? The zeros in each and every factor. So who's a factor? This guy. Who's a factor? That guy. Who's a factor? That guy. In Algebra 1, I'm teaching it that you, like Moses, split the Red Sea. Actually, God through Moses. But anyway, split the Red Sea. Split up each one. Make them all equal to 0.
Oh, that's right.
Good old-fashioned stuff. Just looks weird because we're dealing with much harder stuff than Algebra 1. I don't know about much harder. It was like pre-cal. We had this sort of stuff. Anyway. Alright, no big deal. What do we got? Gotta run in with the next problem. That's why I have you guys fold your page and keep on one side and keep on the other. Most of you ignore that direction completely. Should totally chuck in zeros. That would be fun. It wouldn't, because then you'd have to resubmit it and I'd have to regrade it. Anyway, this guy's easy. It's 0, right? This guy's not quite so easy, but I subtract the 2 and divide the ln3. It's gross, but it's a thing. It's all right. It's a number. Subtract the 2, divide the ln3. And why am I going to box it and be done? Who am I ignoring completely?
Yeah.
Why?
Log 3.
Think of it 2 ways. Think of it with a graph. Is 3 to the x ever going to hit 0?
No.
The other way is you would take ln of both sides. You try to take ln of 3 to the x. No big deal. The x comes down. X ln of 3. I can do that. If I try to take ln of 0, I wish. Does ln ever hit 0? It doesn't work. It's impossible. ln of 0 is a vertical asymptote, so nope. You're like, wait, that's a DNE! No. I mean, this does not exist, but 0 is not a DNE of up here. I mean, it is, but for a different factor. This little DNE is saying this can never happen. This can never happen. If this can never happen, okay, then fine, ignore them. If I were you, I would go find whatever AP, like colored pen, AP highlighter, something you've been doing, because they love to throw exponentially things in places where you want to find zeros. And you need to basically remember the pre-count that any exponential equal to 0 is impossible to ever happen. Now, if you're good at logarithms, taking ln of a 0, you're like, oh, never mind, that's right, it doesn't work. Just a couple of you were like, 1! I know, because ln of 1 is 0, but ln of 0 is an asymptote and does not exist. Asymptote. Jacob Gigante still lives. He graduated a long time ago. Yep. Impossible for 3 to the x to be 0. So he doesn't contribute at all to the equation. If he can never be 0, well then he can't give us a 0, but he can and he can, so those are the only 2 zeros. That kind of makes sense?
Yeah.
Okay. What were we just practicing?
Homework.
Why?
Is that homework?
Because there's a huge section of homework that says find the critical. How are you going to do it? Think about domain of the original function. Then go looking at the derivative, get it as simplified as possible, and then ask yourself, based on how the derivative looks, how do I find a 0? If it's a fraction, look at the top. If it's another function, just set it equal to 0. Maybe factor. Then think about DNEs. Ah, it's a fraction. There are DNEs. Well, go find them and make sure that they fit. He doesn't have any DNEs. Okay, fine. Then don't look at them because they're not there. Okay. Talked about this yesterday. Why Is B and C and D, why did I label those as critical numbers but not A and E? What was going on at B and C and E? Sorry, B and C and D. What was the slope at B?
0.
What was the slope at C?
0.
What's the slope at D?
Does not exist.
Does not exist because the two little slopes do not agree. It's a sharp point. Coming back to continuity and differentiability, the derivative does not exist at a sharp point. So wait a minute. It's a 0 of a slope, a 0 of a slope, a d and e of a slope, and aren't the slopes the derivative? Oh, the zeros and d and e's of f prime. Of course it's a critical number. Okay, moving on.
Oh boy.
We need to talk about absolute extrema. I'm going to dual page it and see if we can see it. We're going to talk about absolute extrema. That's the next big section of homework. After they say just practice with critical numbers, then they say find the absolute extrema. The question that has not been asked or will not be asked in homework without a graph is relative extrema. That's a question for another day. On a graph, you can talk about relative extrema. On a graph, you can talk about relative extrema. But with functions, you're either going to be finding critical numbers or absolute extrema.
That's so funny.
Hold on, guys. I need to fill in something. I haven't found, at least in this program, how to do the nice little element symbol. You guys know what I mean by element symbol?
Yes.
Little like X's within. I haven't figured out how to do that. Decided to throw him in. And then, oh, I need him over here. Let me give you a second to relax, catch up with each other, and you can get this written down. Sound good?
Sure.
Do you have all my little elements of? Yes.
So Miss B,
Yeah.
today on the way to school, a cop started coming, and it's like we're around school, and there's a lot of people on the road. So he's like literally getting on the other side of the traffic. He has his lights on.
Oh, because he's trying to go.
Yeah, so he's like going around, and the people are like people don't understand. Like people try to turn, and they're about to turn at red lights. But like the guy got over, and then when the light turned green, he rolled into people. So it gets the later it gets more crazy.
Where was I anyway? Oh, North Hollywood. I was going to the gym out there, and yeah, I've got like 4 different accidents, and that was just on like surface streets. I'm like, you gotta be kidding me.
Yeah, I almost got in an accident during McKinsey because I'm trying to get in front of all the traffic before then there's a Prius pulls so far out, and she's not even looking at me, and I kind of like a diagonal, and then I go around her, and like, and her face, she's just like,
Yeah. You're like,
oh, okay.
please stop driving. But in all the stupid people's defense, I can definitely be a stupid driver too.
Yes.
You know, like if you're tired or if you're distracted or if something just really sad just happened, or like, man. It can be so easy just to be so dumb. Defensive driving. Much safer than offensive driving. Someone's taking a driving test. They have their little driver's handbook. Oh, and Janelle, she's starting her driver's lessons. I think AJ is taking a driving test. Guys, skip a line underneath that extreme value theorem. Extreme value theorem, oh my goodness, we have intermediate value theorem, we have mean value theorem, and now we have extreme value.
Yes.
I think I feel a yellow box. How about you guys?
I don't feel like all
No? Too bad.
Another
Forever number 21.
21. It's stupid. No, man. That's not first hand.
From the 5th grade.
Was that 5th grade? No. Yeah. It was 6th grade for me. Intense, man. Oh, my session is card on the forever quiz.
Well, it'd probably be either this or this. Probably not both. Exactly.
Sure.
You're welcome.
I should bet for the class that has to get the paragraph.
What should be yours?
Yeah.
Question is, which class do I think deserves a harder one? Is it the poor people that have to come in right away and take it? Or is it the poor people that have to go through their day and then randomly remember it? Or is it the poor people that no class has taken it yet? Is it the class where someone has taken it yet, so maybe they don't have to worry about whatever questions the other class has? Because of course we always tell everyone the questions on all of our tests.
We're humans, Steve.
That's not a good excuse.
But it's fake.
We're humans. We should just do stupid things all the time. You guys feel it. Well, maybe you don't feel it. As a teacher, knowing that these days everything gets spread everywhere. Well, we have to rethink some policies actually, just from the last week or so. Things that teachers have been noticing that are disturbing. Or office people are actually probably the ones to suffer, which really stinks because they already have hard enough jobs.
Or have what?
Just stupid stuff going
Like that underwear? Or have what?
Nice.
Champion.
Self-champion.
Sad thing is, every time someone cheats, they make someone's life harder. It's a very selfish thing to do. But anyway, as a teacher, you guys have to realize that sometimes I do be like, oh, I'll give them this and I'll give them that. And sometimes it's like, I bet they told them they had this, so then they're going to actually study the other, and then I'm going to give them the original one. It just depends. I do a little bit of both. Why? Well, sometimes I have to teach it your own game.
But what happens if I tell them study both on the card?
That's what I told them the day before.
What
So
happens
your
if I just
integrity is
tell them-
intact, and then they're going to be ready either way.
Yeah, what if I just tell them it's hard? Then I know.
Hey, I don't mind that. I used to say that after every single test. I might tell them what I told them. Was related rates on there? How about derivatives of inverse? Yep, I literally told you guys the topics of every single question. And some of the questions were the exact same as the practice. Rough. Yet some people still try to get more information. I don't even know. Blows my mind. Okay. Finding absolute extrema with closed with partially open. What? Closed and open? What on earth are we talking about? The front door? No. Look, the intervals. Right? The intervals. So, okay, before we even get to this, if you guys notice, there's this huge, steps for finding absolute extrema. What am I doing? Summarizing it in a way that you'll remember it because it's in a forever card you should study. How long? Forever. At least this year. Okay, so, extreme value theorem. EVT. Extreme values. Oh, maxes, mins. All right, cool. If f is continuous on a closed interval. That's right. Yesterday we saw if there were discontinuities, some mistakes could happen or some things could be missing. So only if f is continuous on a closed interval, no holes at the endpoints, then f must have both. Underline both. The only time you are guaranteed that a function will have a highest and a lowest, even if it might be at multiple places like a sine or cosine. But it will have a highest and will have a lowest value is when the function is continuous on a closed interval. And those values will occur at either endpoints or critical numbers. Hey, critical numbers, forever card number 20. When the function exists and the derivative is 0 or DNE. I know who that is now. Yes, forever number 21. Forever 21. So fun.
Forever 21.
Something happens every year. Okay, so finding absolute extrema. Well, let's talk about this and then let's summarize it into two little baby statements over there. Steps for finding absolute extrema, the absolute highest and the absolute lowest. Values. 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 Function values, not x values. Values. Okay. Find critical numbers of f. Oh yeah, we kind of figured out those are important. Evaluate f at each critical number. Evaluate f. Evaluate f at, hey, look, critical numbers and endpoints. That's what I just put over there. What are we doing to them? Evaluating f. What does that mean? And then the extreme values of f of x wins. The greatest one is the max and the least one is the min. Well, that seems easy. Evaluate f at. Doesn't this sound like f of? With closed intervals, all we have to do is test f of all the crits and the endpoints. F of all the crits and endpoints. Now, is that a very precise way of writing that? No, it's an awful way of writing it. But I wanted to do that instead of saying like f of d, and d is all the crits and the endpoints. F of, we're plugging into the original function. Whoever the original function is, not the derivative. The original function. We're plugging in all the crits and the endpoints and saying who's the highest, who's the lowest. With partially open. All bets are off. With partially open, the extreme value theorem does not apply. All bets are off, but that doesn't mean it doesn't have extrema. It just means we don't know which ones are guaranteed. Remember, these theorems are guarantees. So with partially open, what do we do? The same as above. Additionally, considering, so sad, behavior.
You should just put an addition sign.
Yeah, I was going to, then I thought it'd be too confusing. Does it not? Okay. Close answer. Plus function behavior. There we go. Wait, function behavior. I thought function analysis is what this entire chapter is. So in homework, you probably aren't going to be doing this one yet. The first one says if it's on a closed interval, continuous on a closed interval according to my theorem, then all I have to do is test f of all the crits and the endpoints, looking for the greatest and the lowest, the highest and the lowest. But if they give me a partially open interval, it's not that I can't do it, I just don't have it guaranteed. It's not as nice and neat and simple or straightforward, and so I would do the above also, but I'd have to do this additional, like think about the function behavior thing, and we haven't learned all that yet, so we're just going to say it's a thing. Hold on, it's coming. So, the second part of homework is find absolute extrema. We're going to start with an easy one. Polynomial. Why is he easy?
There's no domain restriction.
There's no domain restriction. So he's continuous, right? This function is continuous. Why? He's a polynomial. He has a closed interval. Nice. Continuous on a closed interval. So what do I know is already going to happen? He's going to have a highest. He's going to have a lowest. EDT applies. And also, what makes this a really easy function? Well, if he's continuous on a closed interval, I know all I have to do for absolute extrema is test the candidates. If you want to, we could say f of the candidates. Because this is an f, right? F of the candidates. Hold on. According to your theorem, what are the candidates for absolute extrema again? So I have to go ahead and find my critical numbers. And, oh, my endpoints are right here. That's no big deal. My endpoints. How do I find my critical numbers? We already know his domain. It's all real numbers. We have our interval, where to look. All we need is, that's why he's easy. Look. What an easy derivative. How fast was that?
So fast.
Critical numbers. DNEs will never happen. It's a polynomial. There are no DNEs of that, but what are there? Zeros, yeah. So go looking for the zeros. Why am I going to say x equals plus or minus 1? Would you have gotten there? Would you have pulled out the 6 and seen that it's x plus 1 times x minus 1 that's equal to 0?
Yeah.
X squared minus 1 and factor. But why, when it comes time to test, and I just try to simplify it?
You're only going to have one positive one.
Why am I just going to plug in 0 and 1 and 3? Why didn't I plug in negative 1?
Because it's not in there.
I'm only looking for the ones in between the endpoints. Wait, why are you making a table? Well, because I have to test. Well, how do you test? Will you evaluate F?
Plug in,
And what does
plug in.
evaluate F mean? Plug in. Plug in the candidates. To where? To F. Why? Because I want to know how high he goes or how low he goes. And the only way to know that isn't looking at his slopes, it's looking at his Y values. So plugging in 0, I get, well, 0, that's boring. Plugging in 1, I get, oh, -4, it's lower. Plugging in 3, I get 27, 54, 54 minus 18, 36. Double check, someone, mental math. Give me a head nod, give me a thumbs up, give me a something.
So
Tell me the right
it's
answer.
57.
58. 54 minus 6.
Oh, no, minus 18.
Oh, just kidding. I was doing it into that equation.
Yeah, I'm right, right?
Yeah.
That was a yeah with a question mark. Or
Yeah,
sarcastic.
you are.
Stop, you didn't do that. All right, so what's my absolute max of and at? Oops, I need my blanks. How high does it go and when does it get there? How low does it go and when does it get there? How high does it go? 36. When does it get there? 3. How low does it go? When does it get there?
1.
Nice. Dun, 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 dun. Oh, that was easy.
You do the next one?
Why?
Because the fraction.
You see it? It was a polynomial. The derivative was easy. Does that make sense?
Yeah.
So yeah, we better go get one of those ones where it's a little bit harder. I know, right? Me too. Here we go. Single favor. Ah. I'm gonna do this too. Nope.
Oh,
Entry, yeah.
Like Annie.
And Gail.
Hey guys, I'm gonna go fast with the derivative. Why don't you guys beat me? Ready, set, go. Find the derivative. Ah! Look at the backboard. What are you supposed to do with those derivatives? Look at the backboard. What are you supposed to do with those derivatives?
Simplify.
Get them simplified.
Oh, should we all look at
Yeah, forever. That about
Oh.
I looked
I don't
there.
know why.
Backboard. You guys did them too.
Oh, there. Get those rings simplified.
Got 'em. I'm trying to give you at least a couple seconds to start. Get those derivatives simplified. Let's get them simplified. You gotta get them first, right? Sorry, Austin, you're up here by yourself. Usually there are people around. Sick.
Adam.
You didn't hear Kathleen? She said it like right at the beginning. You guys are all matching too.
He was getting caught in traffic. Mine is 1 mile route to school.
It's mom. But if I do the wave where I want to turn left, it's like 2 miles.
Stop. Focus. Oh, guys, isn't this kind of nice? Like it's already a fraction. There's no like weird square roots or complex fractions or either lens. Oh. And t minus t is 0. Isn't the top just 3?
Can I reduce the 3s?
Can you answer that definitively so that someone who might have actually done
No, you
Thank you.
No,
cannot.
because you're
Yeah,
That's
right?
killing
Puppy,
all
right.
things.
You're killing
Everything.
not a puppy,
Okay.
a cat.
well, I'm
They're
down
so
south.
much cuter than a cat. I mean, I like cats too, but some of them are mean. How do I find critical numbers once I have the derivative nicely simplified?
You separate
Okay? Because I'm looking for
zeros on the top and D&E on the bottom.
zeros are technically just setting equal to 0, but this comes up, so I'm just looking at the top. And then D&E's I'm looking at the bottom because it's a fraction, right? Okay. So set 3 equal to 0. Does that ever happen?
No.
So does this guy have zeros?
You do.
No, he doesn't have any zeros. It's impossible. Set the bottom equal to 0.
Yeah.
Now some of you are like, okay, I need to square root both sides. Yes, you do. Square root of 0 is 0. Aren't you looking at what makes this 0? Negative 3. Wait a minute. What was negative 3 to begin with? What did we not think about? Isn't t not allowed to be negative 3 anyway? Aren't we supposed to think about where it exists, it being the function this time is named h?
Yeah.
Oh, okay, we should have known that. So technically, is this a critical number?
No.
Oh. Wait, he's a discontinuity! Ha! If the function is continuous on a closed interval, this one's not continuous. I get to stop. Wait. Is it continuous on this closed interval? Yes, because this is outside of it. But wait a minute, I have no critical numbers. Well, if the candidates for my absolute extrema are critical numbers and endpoints, and I have no critical numbers, who are my only candidates?
Endpoint.
Okay. So let's test them. We went looking for critical numbers, we didn't have them, so okay, fine, we'll scribble them. We're still, oh, it's not an X, sorry, I apologize.
Wow.
I apologize. We're plugging in T, stop. But it's okay, yes, I make fun of myself. H, T. You try talking nonstop.
Oh, I did.
At the front of the room in teaching fashion. Over kids that are all constantly distracted. Yeah, we know. Negative 1. 6. He's okay.
I'm fine.
It's okay, you wouldn't be Kyle.
Hey, what are we supposed to do? Plug it in where?
The
The original. Not the derivative. The original. We want to know how high, how low. So, plug it in, plug it in. Negative 1 over negative 1 plus 3 is negative 1 half. 6 over 6 plus 3?
9, 1/3. 6 over 9.
There you go.
I love you.
Yeah.
Good job, Wyatt. He was double checking.
Yeah, why?
So what do we know from this table? Oops, too fine. Too high. I should just stop talking. Absolute. Now you might be like, ugh, you're writing even more than the answer key does once you start checking. But the reason is I know AP questions are coming where you have to see the word of and be like, that's a Y, not an X. And if you don't make that connection, well, there goes another multiple choice down the tubes. Max of. How high does it go?
2/3.
How low does it go?
Yeah.
Where's the 2/3? I know where you want. Where's the negative 1 half? Done. What have we done today? Well, yesterday we talked about extrema. We talked about the difference between absolute and relative, especially when looking at graphs. Then we talked about what are critical numbers. Today we figured out how do you find them. Then we talked about absolute extrema. When are they guaranteed? And how do you find them? And then, well, I guess we could have kept going to nastier and nastier and nastier functions. But guys, there were a couple graphs that we ignored a second ago. Did you guys draw those sketches?
Yes.
Okay, real quick. We just talk about what's going on in these pictures. Oops, they're asking us for where the absolute extrema occur. Now, I'm not going to go through and do like A's and B's and C's and D's and blah. Let's just label them real quick. For this function, on this interval from A, okay, I am labeling a little bit. From A to B, where are the absolute extrema? Endpoints or critical numbers? Because the absolute max is here, which is a crit, right? The absolute min is here, which is a crit. How about this guy from A to B? These ones are at the endpoints, right? For the highest and for the lowest. So sometimes, this is like the one we just did at the endpoint. Sometimes just the critical numbers. And sometimes,
They're both.
isn't it at a crit and at an endpoint? So why are we testing them both? Well, because who knows where it's going to end up being. Sound good? Woo! Tonight, you got to find derivatives, get them simplified, and use them in the right way. Try it.
Yes.
Bye, guys.
We actually did so much today.
We did.
We did so much.
Do you see how many examples?